Hey everyone, I hope you're doing well today. In this video, I'm going to be going over a tutorial on how to do some statistical analysis on a dataset. Before we can get into doing some statistics, we're going to have to go ahead and first start with a statistical question before we can collect some data. So for this tutorial, I'm going to ask the question, what was the population of each state in the United States in 2019? That'll be our statistical question, okay? Then we go ahead and collect some data. So did a little bit of research and let's go ahead and type that in. So this will take a little while, so just bear with me. Okay, now that we have all of our 50 states, now let's go ahead and find out what their state populations are. So I'm going to type those in next. And bear in mind, this is the most tedious part of this poll process. So once you get this done, the rest of it is going to be a lot faster. So now that we have all of our data input and you've double checked it and triple checked it and checked with maybe somebody else just to make sure it's all accurate, we can begin some actual statistics. Okay, so let's go ahead and work on the measures of center, variability, and just some overall summary. So for observations, well, we should have 50 states, but let's just go ahead and count these up. So we could do equals count, C-O-U-N-T, open parentheses, and this is where we want to select our data. So it looks like our data starts in cell C4 with the population for California. So I can type in C4 and that should highlight that number. It should turn orange here and hit a colon, and let's see where it ends. It looks like Wyoming is going to be the last one. So that's going to be 578759. Okay, so I should say C4. I somehow clicked out of that, and that should be C53 for me. So C53. Okay. If I hit enter, it's going to count how many numbers there are, and that's the number of observations. So there's 50. And what's nice about that is, just say we got rid of one or we had one less observation, it'll update automatically for us. Okay. For the minimum, we're going to hit equals and type MIN. That'll be the function. And let's highlight the same data. It's going to be C4 to C53. Just try to remember that because we're going to keep reusing that. And what's nice is it'll find us our smallest population right away. And they're already in order, so this is kind of, redundant, but it will help us out in case anything does change. So equals, for the maximum, we'll do equals max. And that'll also be C4 to C53. It'll help us find the maximum right away. And no surprise, that's California. For the range, we will just do equals, and we can click on this maximum value, or J6, and just subtract the minimum, which is this population over here. So equals J6 minus J5. That just says, please, we want the computer here to just subtract these two values for us, no matter what they are, and it'll tell us the range of the data. So that is how far the populations range. Now for the mean, there is no the command isn't going to be using the word mean, but it's actually going to be the word average. Okay, so we can find the average and put C4 to C53, and that will do it very quickly for us. That's the average population. For the median, this one's nice and easy. We can do equals median. We'll do C4 to C53. That'll tell us the median. For the mode, equals mode C4 to C53. Whoops, okay, it's going to say nothing is there because there's no mode. None of the states have identical populations to others, so that's perfectly okay. For this M.A.D, this one's going to require a little bit of work here. So for the mean, let's go ahead and type this in. We'll do equals over here in this blue column, and we will go ahead and click on the mean or this J8 cell. Okay, so now if you type that in, and we just go ahead and see, that'll be the average, which matches the 6,551,896. That matches right over here. If we drag this down, it's going to show us that it doesn't continue the pattern. So a little trick for you here, double click. So it says equals J8, right? Which is we're just telling us to equal whatever it's in this cell over here, which is that mean value. Now, if you go ahead and just put a $ before the J and put a sandwich of $ around the letter and hit enter, nothing really happens. It stays the same. But what's neat about this is now if you click on this blue square, you can now drag it down to the last state and it just copies it all the way down for us. So that beats number one, typing it over and over or writing it over and over. And we also don't have to copy and paste it, anything like that. You just drag it straight down. Okay, so these are, right now we have the original data to the left. All right, and then we have the average to the right of it, a column of all the average just repeated. Now let's find each of the deviations. Now to find out each deviation, I think California is going to have a pretty big deviation, but to find out how far California is from the average, we can take California's population equals C4 and subtract the average here, and we get a pretty big deviation. Okay, you can, if the suggested autofill shows up for you, great. If it doesn't, let's pretend it didn't pop up. What's nice about this is you can click on this blue square and drag it down, and it should do all the deviations for us, right? So California is way above the average. Texas is also way above the average. Florida is also way above the average. And as you make your way down to states like Missouri, you can see that it has a negative deviation because its population is below the national average, right? And as we go further down, each of these states has a bigger and bigger deviation under the average population. Okay, so hopefully that makes sense. And now that we have our deviations, we can find our absolute deviation. So going over to this column to the right, we can hit equals ABS. That is the function for absolute value. And if we click on E4, it'll tell us the absolute value. And remember, if anything's positive, it should just stay the same. And if it's negative, then it'll turn positive. Again, I'm going to pretend this autofill thing's not coming up. And let's drag this down using that blue square. And look, we see that everything that was negative is now positive, and anything that stayed or was positive to begin with is still positive. Okay, so these are all of our absolute deviations. So these are the distances each of the state's populations are from the average population. So some of these are bigger deviations and some are smaller deviations from the average. Okay, so what do we do with all these absolute deviations? Well, we can actually find the M.A.D out, right? So for the M.A.D or the mean absolute deviation, we can hit equals, and it's the average, it's the mean of the absolute deviations. It's the average of the absolute deviations. So that's going to be from F4 to F53. Again, we're not going to average the original data. We already have that. We're taking the mean of these absolute deviations, or the average of these absolute deviations. And there is our M.A.D. It is, while each of these states has a different deviation from the average, on average, they are about 4.8-ish, 4.7, 4.8 million away from the average. There you have the mean absolute deviation. Now, in terms of this last column and the sum of squares, variance, standard deviation, I'll talk about that in office hours or another time. We're just going to go over the main important parts that everyone is required to do here. Okay, so let's go ahead and figure out what the minimum is, which we already know. For our box plot, we'll do equals, and instead of doing anything fancy, let's just link it to this cell here. So if we put the minimum there, it'll just update over here. For the lower quartile, we're going to hit equals, type in quartile, open parentheses, and we'll highlight our original data. That is going to be C4 to C53. But we'll put a comma 1 after that, okay? So this is going to be the equals quartile is, letting us know we're creating quartiles, and we're saying please look from C4 to C53, and the comma 1 lets us know that we're finding the first quartile, okay? So this definitely beats writing out all the numbers from least to greatest and crossing them off and so on and so forth. We hit enter here, that tells us the lower quartile, okay? Now for the median, we could just link it to the median one, but just to practice and show you this again, remember the median is the same thing as quartile 2. So we can hit equals quartile and have it look for the quartile between C4 and C53 for us. And we'll put comma 2 for the second quartile. And just make sure this matches. So this is the median 4.558 million. And you can see that does match the median that we had earlier. This one's rounded to a decimal, this one's rounded to the whole number, so they're basically the same, okay? If we don't want any decimals, that's fine. We can just highlight our data and decrease the decimal places, and you can see these do round perfectly to the correct number, okay? For the upper quartile, we'll do equals quartile, parentheses, C4 to C53, and let's put a little comma 3 afterwards because it's the third quartile, okay? For maximum, we can do equals and just click on the maximum up here. Let's just link that to this cell. And for the IQR, interquartile range, remember that's the upper quartile minus the lower quartile. So instead of typing out the numbers, we can just click on this cell, J20, and subtract cell J18, which is the lower quartile. So I know it says equals J20 minus J18, but what we're really saying is whatever's in those cells, please subtract them for us, and that's really what we're looking to do anyway, right? So hit enter, and that means that our IQR is 5.7 million people, which means that 50% of all the states are have a range, the middle 50% rather, have a range of about 5.7 million. So they're a lot closer together compared to the range of the whole data set, okay? Now, this part, if you didn't know already, how to find low outliers or high outliers, these are just going to be data points that are just very different or very out of the norm compared to every other data point. And the way to find this is you take the lower quartile and the upper quartile, and you either subtract 1.5 times the IQR or add 1.5 times the IQR. Now, I can go ahead and show you this. It's quite easy to do on here. So we'll hit equals, and we need to start with the lower quartile for the low outlier, since the lower quartile is closer to the bottom. And we're going to subtract, we'll put a minus. Again, J18 lets us know the lower quartile number. We're going to subtract 1.5, and we're going to hold Shift 8 to get that star, that's times, and we're going to multiply that by the IQR, or J22. So just pause and think about this for a little bit. Pause the video if you need to, but to find the low outlier, what you do to see if there's any states that are out of the norm on the low end compared to the other states, we take the lower quartile, which is J18 here, and we're going to subtract 1.5 multiplied by the IQR. And our IQR is located in cell J22, which is why I typed that in or clicked on it, okay? When I hit enter now, you're going to notice that it is a negative population. So what this lets us know is that there are no states that are, strangely on the low end here. It's not that uncommon for states to have, less than 5 million people in it, or, even less than 1 million. There were enough states that made it not a weird thing to have low population. But if there was going to be any weird populations, the abnormally low, they'd have to be a very negative value. Okay, so nothing strange on that side. Let's check out the high outliers. So for the high outliers, we'll do equals, and we'll click on the upper quartile. And instead of subtracting 1.5 times the IQR, we're going to add 1.5 times the IQR. So we'll do equals J20, that's the upper quartile, plus 1.5 multiply, that's the star on the 8 on the keyboard, that's Shift 8, and multiply that by the IQR, which for us, that's in cell J22. Okay, so if we go ahead and take this upper quartile and add 1.5 times the IQR, Google Sheets will know that we're doing a order of operations, and it'll multiply before it adds. And this lets us know that if there are any populations that are greater than 16 million, then these states would then be considered outliers. Okay, so let's say think which states are they going to be? Well, the first one we can see California is definitely an outlier, Texas is definitely an outlier, New York, and I think that's it. There's just 3 outliers, right? California, Texas, oh no, I forgot one, Florida, then New York. Okay, so if I want to take these values, these would be the outliers. Okay, and that's basically it, right? So that lets us know that these states would be the outliers. And generally, when you make your box plots, you would leave out your outliers. That's kind of like a common thing to do, but what we could do is we can just kind of create a box plot with it, and I can show you like how it kind of evens things out once we get rid of them. So I'll start off here by making a box plot. So this sheet is programmed already. It's been set up in a way so that we can just put like a title in here. So this is going to be 2019 state populations. It's okay if it kind of spills over a little bit. And if you just click and highlight these 5 cells. It has to be exactly these 5. This first one with the title, the minimum, the lower quartile, the upper quartile, and the maximum. Notice how typically we say there's 5 important numbers, but we're leaving out the median or the second quartile or quartile 2. Well, we highlight these 5 cells and click Insert, Chart, okay, and it gives us a bar chart. Now, you have a bunch of options here, so if you click on Setup, or it should be already on Setup, and you click on Chart Type, then we can scroll down all the way at the bottom right, hopefully it's the same on your computer. We can click this one that says Candlestick Chart, okay? So if we do Candlestick Chart, what happens here is the population or the title is going to be right at the bottom there, 2019 state populations. And you can notice that this like top end of the graph of the box plot is quite long, right? So what's causing that? Well, it's really California, Texas, Florida, New York that's causing the top 25% to be such a long spread out. It's creating a huge variation in the data. So what you can do to fix this, right, is that we typically will take out our outliers. And then if we take out our outliers of California, Texas, Florida, New York, what would be the next highest state population? So let's see, I think it would be Pennsylvania. All right, so if we get rid of this maximum over here and we change it to Pennsylvania's population, which is 12,801,989, this is going to be Pennsylvania, Sylvania. Okay, so if we do that, this box plot is a lot more evenly spread out than before, right? So there's still that higher piece in the top quartile, in the top 25% of biggest states, or most populous states rather. But this looks a lot more evenly spread out without having that Texas or California, Texas, Florida, and New York, right? So if you have any outliers for your project, what you can do is you can take them out and change your maximum to whatever the new maximum is once you identify any outliers. So for this example, there were 4 outliers. It's possible that you don't have any. It just really depends on what you've calculated for your low and your high outliers. So again, for this one, it was the quartile 1 or lower quartile subtracting 1.5 times the IQR. And for anything on the high outliers, it's the upper quartile, and you add on 1.5 times the IQR. And if you see any data values that are above the high outliers or below the low outliers, then those would be considered outliers, and they would be considered, just quite out of the ordinary compared to the rest of the data. Okay, so there we have a box plot. That's how you create one. Okay, you always need to have 5 boxes or 5 cells. The one on the left has to have words in it, and then you need the minimum, the lower quartile, the upper quartile, and the maximum. Okay, those are the 5 things you need to make a box plot on Google Sheets. Now, one last thing that we're going to do here is we're going to go ahead and find out, or create a histogram rather. So to create a histogram, what we can do is we can just highlight all the original data right over there. That's C4 to C53. And once you've highlighted all of the data, you can click Insert, Chart. And what we're looking for is we'd like a histogram. So this isn't what we're looking for. So click on the chart type. And let's go all the way to the bottom. I believe near that candlestick one, there's this in the other section. It says histogram chart. So I'm going to click on that one. And look at that. It just creates a histogram for us. So go ahead and get rid of this. Again, you can play around with titles and things like that. So you can center this. And you can say 2019 U.S. state populations. Give it a nice title. This is going to be number, we'll call this population size, number of people. And let's see, for the vertical axis, we can say something like, this is the number of states. Okay, so if you take a look at this, now that we're done creating this histogram, hopefully you can see that this data, or this histogram in particular, is going to be right skewed, since most states, it looks like, I guess 29 states, more than half of the states have less than this 5.7 million population. And then as you go higher in population, there's less and less states that have it. And then you can see you have our outliers up here with like California, Texas, and so on and so forth, even Florida and New York over here, but that's still quite not normal compared to the rest of the 46 or so states. Okay, so that's basically it, right? So this is a histogram. It has already created the bars for us, and the intervals and the frequencies are all there. And then here we have our box plot. And these are just two ways of kind of summarizing the data. I know it doesn't include the median line in here, so if you wanted to, insert your own, line and draw it on there, that's fine. And typically, if you have an outlier, they would just be like little dots out here. So like Texas and Florida and California and New York, you'd have a little dot that's beyond the normal data. But again, if you weren't going to do it that way, you can always change your maximum back to whatever California's population was. So if you didn't want to do that, which I know calculating outliers is a little bit more work, but it's a little bit more accurate to depict it. But if I go back and change this to the original data, and this is now back to California, right, you can see that it drastically makes it look like the data is just a lot more squished, because just that top 25% is so darn spread out. Okay, so hopefully you found this video helpful in understanding how you can use Google Sheets as a tool. If you're dealing with data sets that are less than 10 numbers, doing it by hand isn't awful, but it still takes a lot of time. But this is a data set with 50 observations, and this would have been very tedious to do by hand or even with just a calculator. So anything that has a lot of data points and you want to look at a lot of number summaries and run some statistical analysis on it and calculate some statistics, it's a lot easier to use some software like Google Sheets to do so. Okay, so hopefully you found this video helpful, and good luck with whatever you're working on for your statistics work. All right, keep up the great work. I'll see you in the next one.